All right, POE, we're going to do some 3.1.3, which is some basic inputs programming. Last time we tested some basic outputs and plugged some things into Robot C and figured out what could actually come out from our test bed that we have over here. And today we're going to take that a step further by adding in some input commands too. Now inputs are things that come from the sensors themselves. So if you were to click on one of the limit switches or press on the bump switch or change one of these rotation sensors, all of these would be inputs. This would be information that comes from the outside and goes into the computer. Outputs are things that start at the computer and then come out into um, the real world, like these motors or the flashlight, stuff like that. These are outputs. These are things that the computer gives us, and these are inputs. These are things that the environment around gives the computer. So we're going to use these inputs to go with it. What we're going to need is, I kind of noticed, I'm going to need a battery to go along with this first and foremost. So let me get a battery to charge. And while I'm talking about that, we're going to make sure that our motors and sensors are set up by hitting the motor and sensor setup button. And we're going to just check and make sure that everything is okay. So I'm going to click motor and sensor setup here. And while I'm doing that, I'm kind of taking a glance and seeing that everything is okay. We're going to go ahead and plug ourselves in. Hopefully I got the right one. Yeah, that just clicks right into place. And we'll get ourselves hooked up with a USB cable too. That moment when you start a video and you don't even realize that you have the thing plugged in. Let's see, plug it in right here. And then we'll plug it in over here. Basic first steps. All right, I'm gonna get some glowing going on. Turn the Cortex on. All right, so you should get green lights all around. Okay, so I'm gonna got some green lights on the Cortex itself. You can see it glowing from there. And we're gonna try to put in some code now. I'm gonna do some basic inputs programming. We're gonna be messing with a couple of these inside. I'm gonna pray that this stuff actually works and that my students haven't messed up the individual things. I can try hitting downloading to robot and checking in the bottom part and seeing if all of these things actually work out the way that they're supposed to. Let's see down here. I've got sensors. Looks like I got some good sensors. Motors, right motor, left motor, servo motor. All right, so I think we're good. So here we go. We're gonna go stop. We're gonna type in some code. Right now that we've got everything where we need, what we're gonna be doing is we're gonna plug in using the natural language what it tells us to do in 3.1.2. And we're going to start off with using the natural language setting, which you can go over and click onto over here, and you can look inside. I'm faster at typing, so I'm probably just going to do that instead. There's a whole lot of intils, and those are usually the ones that come into it. The first thing it wants us to do is say intil bump, and to use the bump switch. So you can click on this and drag it out like this, or you can just hand type it, okay? And it says that it wants us to say that our sensor port, I'm going to erase this, and I'm going to put in our bump switch. So I'm going to type in bump switch. Okay, and it doesn't seem like we need any delay to go along with this. I'm going to try to erase that. This is what it says in the section to do. So I'm going to hit compile and make sure that that actually does what it's supposed to. Yep. Okay, looks like we don't really need a delay there. Next thing that we're going to do is type in start motor. And it looks like it wants us to use the right motor with a speed of 63. And don't forget, you can always just drag these over as well too. Make sure you put a semicolon at the end. I'm pretty sure that I named my right motor with a capital R and a capital M, so I'm going to change that to right motor like that. And then it wants us to wait for 5 seconds. And then after that, it wants us to stop motor and then right motor. Okay, we're going to semicolon that. I think there's not any problems here. We're going to click compile. I'm going to go ahead and do file, save as, and I'm going to call this one 3.1.3 inputs programming, just in case. I'm going to hit save because if this thing freezes up, then I don't want to lose everything that I just did. So I'm going to go ahead and save it, compile the program, and then I'm going to hit download to robot. And whenever I download it to the robot, it should show up over here on the test bed. And whenever I hit start, it should actually do what it's supposed to do. Now, let's see. Let's trace through the program and let's see what it's actually asking us to do. Until bump switch. That's this one right here. So whenever I hit start, it's not actually going to do anything yet. What it should do is whenever I press the bump switch, it should actually start the motor and it'll wait 5 seconds and then it'll stop. Let's try it. Okay, so I'm pushing the motor. The motor goes around for 5 seconds, and then after 5 seconds goes, it stops. So this code looks like it functions correctly. So until I hit the bump switch, don't do anything. When I press it, it's going to start, and it's going to start for 5 seconds with a speed of 63, and then it's going to stop. And that looks good. So mission accomplished on that one. And that's what it wants us to try to go through, is to try to look through these different sensors and see what these different sensors will do. I can change that around. So if instead of saying until bump, I can actually use it on the limit switch as well too. And I can use it from the natural language command and going over until the intils. There's a whole lot of different ones. There's until bump, there's until touch, there's until button press, until dark, until encoder. All of these deal with these sensors over here, okay? And the first one that we did was the bump switch and what it actually does. Okay, we're going to go ahead and keep going down, and I'm going to go ahead and erase this to where I just have my task main, like so. And it looks like it wants us to add another piece of code. It's going to be a little bit different on mine because of the way that I have my test bed set up. So whenever I type the stuff in, these numbers or these ports up here or the names that I named them are going to be a little bit different than what it says. Like for example, this is part 3, number 17. It says use the program below in the task main of the program between the curly braces. We're going to type this in. So the first thing it asks us to do is to type in the command turn LED on. So I'm going to go to turn LED on, but I don't, it says green in that one, but I know that I called mine green LED, so I'm going to use that instead. Don't forget your semicolon at the end, because that's going to be really important to us. The next one says until potentiometer greater than, and I just have to type in until PO, and after that you've got 2 different options. I'm just going to use the keypad and then go to greater than and hit enter, and it fills in the rest of that stuff for me. And then it says to input 2048, and then comma, and then it wants us to call it the potentiometer. Okay, semicolon. And then next one, turn LED off, and then make sure you call it the green LED. And for the next part, we're going to hit start motor, and it's going to be left motor. Oops, I guess I could have left that one in there. And at a value of 63, so it's going to go to about half speed. And then after that, we're going to wait for 3.5 seconds, semicolon. And then we're going to stop the motor, and that's going to be left motor. Okay, semicolon there. And that's all it tells us to put in. And we're going to download and run the program. We're going to see what happens. So I'm going to hit compile, check for errors, see if anything shows up. Everything looks good. Looks like the LED is going to turn on up here. It may be hard to see on the camera. And then it's going to wait until this potentiometer actually has a reading of 2048. So we'll see. I don't exactly know where the potentiometer is right now. I may have to run this twice. I'm not sure if I'm at the 0 side or not. So I'm going to go ahead and hit download to robot, and let's see what happens. So we'll get it going, and then let it load up. My potentiometer right now says it's at 1300, so I can go ahead and just change that to where it goes to 0, and I'm going to hit start. And whenever it does that, this LED light lights up. It's red, if you guys can see that. And then as I move the potentiometer is going to change to different values, and you can see it changing at the bottom of the screen down here. And whenever it passes past 2048, it's going to turn the motor on, and it's going to turn the motor on for 4.3 seconds, or 3.5 seconds, and then it turns it off. So whenever this reached, it went ahead and ran the motor, and then it stopped the motor. Now, if I go back down and I twist it back up again, it doesn't do it twice. And the reason why it doesn't do it twice is because the program runs every line by line, and that's it. If you want it to run the lines again, we're going to have to specifically tell it to run the lines again. It doesn't just do that automatically. It basically is like a big yes boss, and that's all it does. So it says turn the LED on, yes boss. Until the potentiometer gets greater than 2048, just stand still, yes boss. Turn the LED off, yes boss. Is there anything in here that says repeat? No, so it's not going to do that. We're going to have to add those commands later if you want to be able to turn it on and off multiple times. And we'll add that. It's not too bad to change, but we'll do that later. Okay, so what they want you to do is they want you to, you know, figure out what happens whenever you turn this past 2048. Okay, and also you can notice that we did tell the LED to turn off whenever that happened, and the LED did turn off as well. So it looks like this code is working good. Okay, and let's see what else it asks us to do. It says part 4 using the optical shaft encoder. So we're going to use a new snippet of code. So I'm going to go ahead and I'm going to get rid of this. The good news is since it's on video, you can always just go back and rewind it. So I'm going to, bloop, bye-bye, there it goes. Looks like we've got a new piece of code to go with. And it looks like we're going to be using our start motor, which is going to be something that we're going to be doing a lot. So start motor. Um, and as you type these more and more often, it just becomes second nature to just remember what they are. So it gets easier. I know the first time you're looking at it, you're like, oh my gosh, I don't really even know what to do. But I would definitely encourage you to try to practice as much as you can. And as you practice more, it gets easier and easier as you continue to do it. Okay, it also helps if you learn how to spell. So see, I did not spell motor and it didn't highlight in blue. All right, so this is a new code, and it says the new function is until encoder counts. Okay, and it looks like I can go ahead and type that in, and it looks like until it gets to 480, and then we're setting the type to quad, and that's the quadrature encoder. Wait a minute, I don't have anything named quad. We're gonna have to call it something else. What's my quadrature encoder here? It's called encoder. So I'm gonna call this encoder, and then I'm gonna hit semicolon. And then after that, we're going to then stop motor, and it's going to be on the left motor. And we're going to stop motor, and that's going to be on the right motor. Oops. There we go. Okay, those are the 5 lines of code they want us to put in. Let's check, make sure I didn't blow up anything. Oh no, looks like something happened there. Let's check and see. Oh look, no semicolon. Okay, so make sure that your semicolon's in there. I like to compile code that has no warnings and no errors. Some people like to fly by the seat of their pants and use the warnings anyway. I highly recommend against that. Red won't let you do it at all, so if you get any red X's, that's a big no-no. I'm going to hit download to robot, and we're going to see what happens. So we're going to let it load up, get all of our stuff going down here. I'll know that it's actually loaded when all of these things load up. Okay, so I have an encoder, and the encoder is set at 11 right now. As I twist the encoder, it's going to move. So it looks like I'm trying to move it clockwise, and that's a negative value. Okay, so as I wrap my fingers around, you can see how your thumb points down. A clockwise rotation is going to be negative. A counterclockwise rotation is going to end up being the positive direction. So I'm going to go counterclockwise, and it's going to start going up. If I keep moving that to where it gets to 480, it should actually move the motors. We're going to get ready to find out right here soon. So I'm going to keep moving this, and then looks like I messed up. So I didn't pass it through, and it did not count. It counted the 480, but it didn't actually let the left motor and the right motor go. So let's see here. Oh wait, it should have actually started with a, hang on, it should have actually started with the motors on, and they totally weren't on whenever that happened. Um, when it does something like this, go ahead and hit stop. And sometimes with the natural language, whenever you're using start motor and stop motor, sometimes it helps to add a wait time. And I don't know why it does this, but sometimes if you put a wait of like 0.5 and then add a wait after, sometimes that helps a lot. Okay, so I'm going to try to just add a couple of lines of code in between here, compile it, make sure I didn't blow anything up, and we'll download it. Now whenever I download it and start, this should actually start with the motors on, and that's going to be a good indication that things are actually working a little bit better. So let's go ahead and turn our quad encoder back down. I'm going to twist it down a little bit, and then I'm going to hit start. Okay, see, adding that wait time actually made a much bigger difference. Now both of the motors are actually working. And what we're going to do is we're going to move this quadrature encoder to give us a positive value. And once it reaches 480, hopefully it stops. We're getting ready to find out. So let's go to 480, and there it goes. Okay, so this actually does work. Do keep in mind though, especially with all of the POE stuff, that if you are working with start motor and stop motor, that sometimes you have to put wait functions inside there, and if you don't have those wait functions in, it might not work exactly the way that you want it to. So if that does become a problem to you guys, just add in small wait times in between, and that should alleviate a lot of the problems. So keep that in mind whenever you're working through these worksheets, is that those wait times might actually be really, really helpful to you. All right, so let's see here. It looks like we're going to do another one. So we're going to keep going. So we're all the way up to part 5, and I think this video is getting kind of long. So I think we'll do part 5, and then after that we'll move on to it. I'll make it just a different video. So let's see here. Actually, let's see how long I've got. Oh, we're on 16 minutes. Yeah, let's just go. I'll do part 5 as a different video. I'll talk to you guys later. Have a great time. Thanks for watching this.